Don, we're going to kick things off with you here, sir. What is SAE J3311 and what does it solve?
Yeah, in I guess in simplistic terms, the goal of the standard is to come up with a solution for inefficient power consumption in the modern vehicles. So today, many vehicles have over 100 ECUs, and that consumption is over 200 amps in a 12-volt system, for example. So the standard is targeting the components that traditionally in internal combustion engine vehicles were okay to consume massive amounts of energy because the alternator was ample to source it. But as the industry moves towards centralization, software-defined vehicles, and electric vehicles, that power consumption is not sustainable. So now it's reducing range, increasing battery pack sizing, which ultimately increases vehicle mass and infrastructure wear and tear as well. And there is a lack of standardization vehicle-wide as well. So many automakers come up with their own proprietary power strategies, and then that basically drives silos into the supplier network, where now every tier one would have individual requirements and validation verification strategies for different OEMs. So the lack of standardization creates a lot of revalidation efforts, re-verification efforts, and not a lot of reuse in the industry. The other main aspect is the complexity. As vehicles are becoming more and more complex with ADAS and autonomy, the more stringent and economy and range regulations as well, the standardization is needed to help manage the power policies to deploy safe, performant, and OEM differentiation industry-wide.
Maria, this seems that you can't turn the news on and read the newspaper without reading about data centers and energy. It's everywhere, and this seems to me, for automotive, you're trying to solve a problem that they're trying to solve on the data center side. Why, in your opinion, was it going in so many different directions before the SAE J3311 came around?
Yeah, I think it's kind of like being the perfect storm, if you will, like where a lot of things were happening at the same time. Like the world was transitioning to clean energies, and that put a lot of, it's putting a lot of constraints into the supply chain for battery raw materials and the geopolitical tensions over there. But when we look at the vehicle, I think there has been, what Don was saying, is that there has been this big transition from combustion engine vehicles to electric vehicles. And this has exposed a lot of inefficiencies within the vehicle architecture. And for gas powered vehicles, we didn't really care that much about it. So that's why we had like hundreds of ECUs running at peak power all the time. But when we started switching to EVs, we can't really do that, because even though the charging infrastructure keeps spreading and advancing, it's not the same as with gas-powered vehicles, where there is a gas station every 5 miles. And so every bit of watt that the vehicle consumes means that you'll have less range to get to where you want to be. And so now OEMs have really to think very carefully about how and where they are spending the energy. And that also combined with the fact that we are also transitioning to software-defined vehicles, and we're adding more sophisticated and advanced experiences inside the vehicle cabin, like gaming experiences, immersed audio use cases are coming to newer vehicles. And on top of that, advanced safety features like ADAS and all of that. And all of this is bringing and putting basically way more constraints in the energy management of the system, because now vehicles are high performance computing on wheels. Basically, they are like better than any gaming computing that you can find in the market. And so these processing demands really puts a lot of pressure on the overall ecosystem, on the overall industry. And the problem with EVs is that you can really just keep making batteries bigger, because you're adding more weight to the vehicle, and that even requires more energy for the vehicle to move. And so we really have to think smarter about how we're managing the energy at the vehicle if we really want to transition to a cleaner energy type of transportation. So I really think that the finding commonalities between all the industry players and trying to standardize that, it's really the right way to go here, because demand for raw materials for batteries, for example, is really falling behind. The production is falling behind the demand. So we really have to think about this differently. And that's what we're trying to achieve with this standard.
Simone, why was there inefficient power all this time? Because a lot of engineers that I know personally, they want to make everything better. And they like to tinker and we can make this better. We can make this better. And it seems that, okay, inefficient power, that's a problem to solve. It would seem that a bunch of engineers would have got together and say, hey, this is a really cool problem to solve. Why do you think it wasn't really tackled before?
Well, there was a kind of energy waste from the basic concept of how cars were designed. So in legacy time, ICE vehicles had abundant energy generated from the engine, and additionally, the alternator was adding more load to the engine, the more power you were wasting. So using more power out of the electric alternator was actually a better efficient way to go. And this today is changing completely, because every bit of energy we are saving out of the battery is adding range and is adding or is shortening charging time. So additionally, we are adding new controllers, new sensors, new devices to the cars for ADAS driving, for software-defined vehicles, for infotainment systems. And these are have heavy processing technology. So heavy processing means high clock frequency, which means high energy. So all of these altogether is generating a lot of waste. However, nowadays, a lot of OEMs are already doing some kind of power management, but is not really optimized. This is because they are either turning on the controllers or off if not used at all. And when they are on at full power. So there is no precise, fine-grained optimization of the power consumption for what their task is in that specific moment of the life cycle of the vehicle.